The last radical reaction we're going to discuss is radical addition of HBr across an alkene bond. You should recall that hydrohalogenation reactions of alkenes generate Markovnikov products, which is to say this bromine here is found the most substituted position. In a case where we want to add the bromine to the least substituted position, we can use a radical addition of HBr. So instead of using standard HBr, we'll also include a peroxide, which is a radical initiator, and light. This will generate our anti-Markovnikov product, where the bromine is found at the least substituted carbon. How does this work? Well, after splitting of the peroxide, our radical initiator, we have an initiation step where the peroxide abstracts a proton from HBr and generates a bromine radical. This gives us our alcohol and our initial radical to begin the reaction. Our first propagation step occurs when bromine reacts with the alkene, generating a new radical here. The radical will be at the more substituted secondary position, and we're generating a new carbon-bromine bond. This is very similar to other reactions where the alkene acts as a nucleophile. If you think about the radical bromine here, as lacking that extra electron, it's more of an electrophile. So the nucleophilic double bond will attack the electrophilic bromine radical. Again, this generates the radical here at the more substituted position. Finally, in order to keep this reaction going, we need a secondary propagation step. We need to regenerate this bromine radical. So our secondary radical in this case will abstract a proton from HBr and generate the new bromine radical, which can then continue on in further propagation steps. Again, this will add the bromine at the least substituted carbon and a hydrogen at the more substituted carbon, opposite of what we see in a typical hydrohalogenation reaction.